All right, let's take a look at problem 6. Triangle ABC is dilated using D as the center of dilation with a scale factor of 2. So let's look, before we go on, let's look down here. A, B, C. And here's the new shape because I see the primes, A prime, B prime, C prime. That's the image, that's the pre-image. It says it was dilated using a point D. I don't see D on here, so that's a little weird. Let's read on. A, where is the center of dilation? Mark it as a point and label it D. Okay, so they're saying that we don't actually know where it is. So one thing we remember from previous problems is that the center of dilation is always a point from which all the other points sort of originate, right? So if we look, we're going to see that we know where the points are, A and A prime, C and C prime, but we don't see those lines that kind of guide us to how they were created. So I'm going to use my ruler here, and I'm going to make some lines that go through the corresponding points, like C and C prime. I'm going to take this right here, and I'm going to do a similar thing right here through A and A prime. I could do the same thing with B and B prime here, and make sure I lead it back. If I keep on doing this, one thing I'll notice is they should all come back, and you'll see if I line it up here, if it's drawn correctly, and I believe it is, they all come back to this point where it crosses back here. They all sort of shoot back to here, and there's D, my center of dilation. So everything, all the corresponding points, just make those lines. Kind of the opposite of how we started by drawing the lines. We're drawing the lines now on the shapes that we already have. So we found it. Next it says, label the side and angle measurements in triangle ABC. So here we already know all the measurements. Here we're missing all the measurements, but we know something. The scale factor is 2. Okay. So if the scale factor is 2, that means we have to think something was multiplied by 2. Well, it must have been the lengths on this guy to get here. So everything here was times 2. So to go the other direction, of course, we're going to divide by 2. Now be careful. There's some things that don't have to get divided, and those are going to be the angles. Angles in similar shapes, in scale copies, are all going to be the same, meaning we shrunk this down, but the angle is still the same measure because, and you can see that in the right angle here. This is definitely a right angle. That's a right angle. So this right here is a right angle, so that's going to be 90 degrees. 71 stays 71 over here, and 19 goes to 19 right there. So those are all going to stay the same. It's just a smaller version of the same shape, but the width of these angles did not change. And I could even use the transparency and match these up. If I traced this angle, it would match up perfectly with that one. We could see they're the same size. But the side lengths definitely look shorter. And we know that that's going to be, we can divide by 2 to sort of reverse the scale factor there. Okay, so let's reverse that scale factor. Divide by 2, 12 becomes, divided by 2 is 6. 12.4 divided by 2 becomes 6.2. Whoops. And the last one is going to be, that's kind of hiding right here, 3 divided by 2. And if I need a calculator, I can use that. This is going to become 1.5. And there we are. So we were able to find the center of dilation, and we were able to write in the angles as the same, but the side lengths as being proportional according to the scale factor of 2 here. In this case, we had to divide, not multiply, because we were making smaller. All right, there you go. Good luck.